After decades of importing base stations from abroad, India has begun manufacturing its own 5G gear. For generations, the global telecoms equipment industry was dominated by the West. Western vendors built most of the equipment, but later Chinese vendors started taking over most of the rest of the world, excluding India. But now, Western incumbents like Ericsson and Nokia are watching their Indian stronghold erode as local Indian players claw away market share. And beneath this shifting landscape, a deeper tremor is building. The coming wave of vRAN, AI networks, and 6G threatens to shatter the proprietary vendor lock-in that has protected incumbents for decades, throwing the industry's future wide open. In the late 2000s, after having been late for 3G and 4G mobile revolutions, India wanted to be at the forefront of the upcoming 5G revolution and bring fast internet to its more than 1 billion population. However, they aimed to achieve this by utilizing Indian technology and equipment. BharatNet was the world's largest rural broadband project using local equipment to connect 300,000 villages in India from between 2013 to 2017. The Indian government employed CDOT, the Research Center for Development of Telematics, to develop telecoms equipment, including base stations and DWDMs for the project. The first of such agreements was signed with VVDN Technologies and Wisig Networks to develop 5G Open technologies. CDOT also worked with Tata Consultancy Services and Tejas Networks to develop and test India's first indigenous 4G network on the state-owned telecoms company BSNL's network. In 2022, a group of private companies and state-run research institutes, led by CDOT, GeoRadars, VVDN Technologies, and Wisig Networks, announced they were set to roll out 5G radios for commercial use in the coming year. CDOT had successfully developed prototypes and proof of concept for these 5G radios. The 5G core software and radios were developed entirely in India. This achievement places India among a select few countries with its own 5G technology. CDOT is already part of a consortium led by TCS chosen to deploy 4G technology. However, CDOT's role is limited to technology development and signing of technology transfer agreements with vendors who will commercially deploy it. In 2023, they signed a consortium agreement with industry partners Lekha Wireless, Signaltron Systems, Sooktha, and Resonous Technologies to jointly develop a disaggregated 5G radio access network solution. The Indian government's gambit was a huge success. It helped the country connect more than 1 billion people to fast internet while also helping build a local telecoms industry. So while Indian firms are not yet global leaders like Huawei, Nokia, or Ericsson, they play a significant role in their domestic markets and are gradually expanding internationally. The Indians also developed their own 5G standard, the 5Gi. 5Gi is a local 5G standard developed in India via joint collaboration between Indian research institutes, IIT Madras, IIT Hyderabad, the Telecom Standards Development Society, and the Center of Excellence in Wireless Technology, CIWIT. In comparison to the global 5G standard, the 5Gi standard uses low mobility large cell technology to extend 5G connectivity and the range of the base station. It does so by using bands of the frequency spectrum, which are lower than 5G's operational bands, but offer higher range waveforms. This technology increases the distance between 5G cell sites from about 1.7 kilometers to 6 kilometers, reducing the number of cell sites required to cover the country and making deployments much more cost-effective. The emergence of mobile telephony in India during the early 1990s coincided with a period of profound economic and social transformation. India had just begun liberalizing its economy in 1991, opening the door to private enterprise, foreign investment, and consumer culture. Early mobile phones in India were prohibitively expensive. Handsets cost tens of thousands of rupees and call rates were among the highest in the world. As a result, early adopters were a narrow segment: business elites, bureaucrats, film stars, and celebrities. In a country where landline penetration was low and waiting lists for telephone connections could stretch for years, the mobile phone became a powerful symbol of privilege and access. Early mobile phone culture was concentrated in India's major urban centers: Mumbai, Delhi, Bangalore, Chennai, and Calcutta. In these megacities, mobile phones became tools for navigating traffic-heavy commutes, expanding business opportunities, and the rapidly growing service industries. The mobile phone fits naturally into the rhythm of urban India, where long travel times and unpredictable infrastructure made mobile communications especially valuable. India's early mobile phone culture was deeply intertwined with the rise of entrepreneurship and informal economies. Small business owners, traders, and service providers quickly recognized the value of mobile connectivity. In a country where formal institutions were often slow or unreliable, the mobile phone became a tool for economic improvisation. It allowed individuals to bypass bureaucratic delays and operate more efficiently within India's vast informal economy. Mobile phones allowed people to maintain ties across states, regions, and small communities. For migrants working in the cities, the mobile phone became a lifeline to families in rural areas. In India's public spaces, buses, trains, markets, and offices, mobile phones use quickly became visible and audible. Taking calls in public demonstrated status. Visible handsets became fashion accessories and ringtones became markers of identity. Indian media portrayed early mobile phones with a mix of excitement and skepticism. On one hand, they were celebrated as symbols of progress, global integration, and technological ambition. On the other, they were criticized for encouraging ostentatious displays of wealth, reinforcing class divides, and being tools of corruption or political influence. Bollywood films in the 90s often depicted mobile phones as glamorous accessories of wealthy characters, reinforcing their symbolic association with success and modernity. The competition for 5G supremacy in India is a strategic contest between two of the three largest conglomerates in the country, the Tata Group and Reliance Industries. The men controlling these conglomerates are Mukesh Ambani for Reliance Industries, Gautam Adani for the Adani Group, and Ratan Tata for the Tata Group. These three represent different facets of India's economic power. Ambani controls the consumer ecosystem, Adani builds and controls the infrastructure, and the Tata Group is mainly into manufacturing and industry. Mukesh Ambani's Reliance Industries began in petrochemicals and textiles, but has radically transformed under his leadership. Ambani's most significant impact has been through the Jio Infocomm mobile provider, which launched the telecoms revolution in 2016 by offering ultra-cheap 5G data. This move helped democratize internet access for over 450 million Indians, helping Jio become the largest mobile operator in India and the number 3 in the world. Today, his empire is a triad of oil and petrochemicals, digital services, and retail. Reliance Industries announced in 2020 that its Jio Platforms subsidiary had designed and developed a complete 5G solution to provide locally made equipment for the Indian market. The Jio Infocomm subsidiary is the mobile telecoms operator, whilst the Jio Platforms company makes telecoms equipment. At the 2023 annual general meeting of Reliance Industries, Mukesh Ambani revealed that Jio was creating its own 5G technology for its current rollout. He announced that Jio Platforms had created a comprehensive selection of 5G radios ranging from small cells to large tower-based radios effectively serving various outdoor and indoor scenarios. The website for Jio Platforms offers an end-to-end 5G portfolio including radio units, network core, and automation platforms. Back in 2020, Reliance Jio, along with its subsidiary Radisys and Qualcomm, started developing Open RAN 5G with Qualcomm processors. Qualcomm also partnered with Bharti Airtel, helping them launch 5G networks in India using Qualcomm's RAN platforms. They also used AMD chips to power their radio units. Jio Platforms is in the process of localizing most of the simpler components of a base station. They produce the filters and radios together with American electronics company Sanmina at their Chennai factory. Their Radisys subsidiary designs virtualized baseband software for Open RAN compliant small cells, enabling cloud-native orchestration. But they still use a lot of foreign components in their units. They use NXP power amplifier modules for their small cells and MIMO antenna systems. Qualcomm and NXP also supply processors for fixed wireless access and small cell solutions. Geo Platforms has developed its 5G core, which is now active within its sister company's telecoms network. They have also launched an Open RAN solution and are managing all services in-house. But there's still work to do. To be recognized as a trusted carrier-grade supplier, Geo needs to scale up its equipment deployment to test and clean up any teething problems. This will help them identify and fix any issues under load and continuous use. Geo Telecom's existing 5G infrastructure was primarily constructed with foreign equipment before they began producing their own. Currently, the network relies almost entirely on 5G RAN technology from well-known suppliers like Ericsson, Samsung, and Nokia. The company aims to make a significant mark in the global telecoms equipment industry and has started exploring smaller markets like Ghana and other African countries that are beginning to roll out 5G services. This strategy will enable them to improve their product range and address technical challenges as they come up. While Ratan Tata died in 2024, he remains the most revered figure associated with the Tata Group, one of India's oldest and most respected conglomerates. Under his stewardship, the Tata Group expanded globally with landmark acquisitions like Korok Steel and Jaguar Land Rover. The group's influence is vast, spanning software services, steel, automobiles, consumer goods, aviation, and telecoms. The Tata Group has made a strategic and successful re-entry into the telecommunications sector through a focus on indigenous manufacturing. Spearheaded by the Tata Consultancy Services and its subsidiary Tejas Networks, the group executed one of the world's largest 4G, 5G deployment projects, rolling out 100,000 cell sites for state-run operator BSNL. Tejas Networks has emerged as the foremost equipment manufacturer in India. Founded in the year 2000 as an optical network manufacturer, it currently specializes in creating and manufacturing carrier-grade equipment for 4G and 5G radio access networks, offering products like radio and baseband units for base stations. Following its acquisition by the Tata Group in 2021, the company started growing rapidly by purchasing additional firms. In 2022, it added Sankaya Labs to its portfolio. Sankaya Labs was established in 2007 by a group of engineers who previously worked at Texas Instruments. The company initially specialized in communication chipsets for satellites, but later shifted its focus to 5G radios applications. The products developed by Sankaya played a significant role in enhancing Tejas Networks' wireless product portfolio, adding to their existing 4G, 5G RAN offerings. In 2023, the company entered into a technology transfer agreement with Indian State Research Institutes. It acquired 5G RAN technology from a group of academic and research organizations, including IIT Madras, IIT Kanpur, and the Society for Applied Microwave Electronics, Engineering and Research, SAMIR. Tejas Networks' 4G, 5G base station components are sourced from a combination of indigenous developments, strategic partnerships, and collaborative manufacturing. They partner with Western companies like Analog Devices and NSP for semiconductor solutions, including power amplifiers critical for their 4G, 5G radio units. Tejas co-designed radio units using Analog Devices components but handled system integration and optimization internally, reducing size and weight while ensuring Indian compliance. The RF filters are also likely co-developed with Analog Devices as part of the radio unit's front end. Tejas designs and produces MIMO antennas with manufacturing partners Optimus Electronics, producing the antennas at their Noida factory in Uttar Pradesh. Optimus Electronics is India's contract manufacturer that produces mobile devices, wearables, computers, and routers. In 2023, it started making telecoms equipment for Tejas, like the 4G baseband units, remote radio heads, optical network terminals, broadband switches, and routers. Tejas currently occupies about 15% of the Indian market, supplying the nation's rollout of 5G equipment for state-run telecoms provider BSNL and offering backhaul solutions to Airtel. Their products are deployed across various parts of the telecoms network, including cell towers, telecom exchanges, data centers, utility sites, and customer premises. Since its inception, Tejas has shipped over 900,000 systems, consistently achieving a field uptime exceeding 99.999% since 2008. The company's aim is to establish itself as the leading equipment provider from India, offering a comprehensive range of world-class products and solutions tailored to the latest technologies and customer needs. Initially, the focus will be on Indian telecom operators and growing markets in Africa and Southeast Asia. The strategy seems to be yielding results. In the fourth quarter of 2024, Tejas Networks provided 27,000 radios to BSNL, bringing the total number of sites it has equipped with 5G to over 86,000. HFCL Limited is another upcoming player in the Indian 5G equipment market. Since its founding in 1987, HFCL has played a significant role in India's telecom infrastructure landscape. Initially focused on manufacturing optical fiber cables, the company has transformed into a full-service telecom solutions provider supporting India's self-reliance initiatives like Make in India. Over the years, they have diversified their portfolio range to feature state-of-the-art wireless communication technologies, positioning itself as one of India's foremost indigenous telecoms equipment producers. In 2022, they formed a partnership with Wipro Limited, a leading global consulting and business provider, to create various 5G products such as distributed units, centralized units, and cell site routers. That same year, it unveiled a 5G lab as a service, which offers an automated testing environment for collaboration among the private sector, academic institutions, and government entities focused on 5G innovation. The company has achieved progress in 5G technology, developing homegrown 5G radio access network equipment, millimeter wave solutions, and small cell technologies. In 2023, HFCL revealed that it had secured a $75 million order from a local telecoms provider. HFCL's primary markets include leading Indian telecoms providers like Jio, Airtel, and BSNL, along with government projects like BharatNet and few international ventures in Africa and Southeast Asia. The company enjoys a strong market position in optical fiber and wireless technologies, highlighted by its success in delivering backhaul solutions to Indian operators working to expand broadband in rural areas. In the Indian supply chain, AMD powers power radio units for major players, including Reliance Jio, Tejas Networks, and Lekha Wireless. They've also partnered with players like VVDN and C-Dot. Their new radio frequency system on chip, the Zinc UltraScale, is aimed at global markets seeking cost-effective, power-saving, and spectrum-efficient radio units. This is particularly beneficial for emerging markets. AMD also supplies EPIC processors for 5G distributed units and cloud-run servers. In 2019, Signalchip gained attention for creating India's first homegrown chip for 5G LTE and 5G modems. This chip builds on their earlier RF transceiver from 2015, catering to high-performance wireless needs. It's flexible enough to serve as a base station chipset for various setups, from budget indoor small cells to high-performance base stations, adapting well to new network designs like Open RAN. Fast forward to 2024, Wisig Networks, a startup from IIT Hyderabad, launch a modem SoC compliant with 3GPP standards for 5G and IoT. That same year, Signaltron debuted a base station featuring a custom-designed chip made in India. Signaltron has been in operations since the early 1990s, specializing in defense electronics. While not a major player in 5G equipment, the company produces crucial telecom solutions and secure software-defined radios for military applications. In 2024, the Indian Army received 4G mobile base stations equipped with locally produced chips from Signaltron. The military was supplied with 20 units. Several other companies are emerging in the background. In 2024, Indian telecoms hardware firms Lekha Wireless, VVDN Technologies, Galore Networks, and Wisig began live trials of the equipment on BSNL's network. A few years prior, these companies had entered into a technology transfer agreement with C-Dot, granting them rights to 5G Open RAN technology that C-Dot was working on. But that's not all. Sooktha and Resonous technologies are gearing up to enter the 5G race as well. The next few years promise to be exciting, with numerous companies vying for their share of the market. However, the revenue for some of these companies may not be enough to justify investing in 6G technology. This situation will lead to a lot of consolidation, with less successful firms merging, being acquired by larger competitors, or even going out of business. And it's likely Nokia, Ericsson will slowly cede their foothold in the Indian market to more affordable local players. India ranks as the world's second largest market for base stations, trailing only China. Its infrastructure deployment is immense, roughly double that of the United States and the European Union, and significantly larger than any other market outside China. Looking ahead, this gap is expected to widen further as market penetration continues to rise, with total base stations installed potentially approaching the 2 million mark seen in China. For telecom equipment manufacturers, this rapid expansion represents a substantial and sustained opportunity. However, the same cannot be said for local operators who build and maintain this infrastructure. Despite serving a massive subscriber base, Indian telecom operators generate revenues that are only comparable to those of operators in France or Russia, markets with far fewer users. This disconnection stems from the inability to charge margins as high as those in Europe or America, highlighting a market defined by enormous scale but constrained by levels of profitability. India continues to increase localization of its telecoms equipment. In 2024, as part of this effort and to support the Made in India self-reliance policy, two big Indian research centers joined forces. The Center for Development of Telematics partnered with the Central Electronics Engineering Research Institute in Pilani on a special project to build a single smart antenna that can handle 2G, 3G, 4G, and 5G frequencies. The innovation uses tiny microscopic switches called MEMS inside the antenna. This allows one antenna to clearly send and receive signals across all communications bands without confusing interference or noise. This technology will make mobile base station towers simpler to mount, cheaper to build, and easier to maintain, and help India control its own communications future. The Indians have a lot of chip design talent, but most of it is used to design chips for American companies. India doesn't have homegrown ASICs and FPGA chips for its 5G telecoms gear companies. They mostly use chips from American company AMD. India also doesn't have makers of CPUs, accelerators, and network interface cards, so all of these components are imported from Western suppliers. Indian 5G makers like Tejas Networks and Geo Platforms source their key hardware components from the same pool of global suppliers used by Nokia and Ericsson, while also developing some technologies in-house. For high-speed data converters, Tejas has strategic relationships with Analog Devices forged through Tata's alliance with that company. Other mixed signal vendors like Texas Instruments and Resonous also provide converters that are widely used across the telecoms industry. In the radio front end, Indian companies source power amplifiers from global radio frequency and gallium nitride specialists including Qorvo, Maycom, Wolfspeed, Skyworks, and NXP. On the compute side, Geo Platforms has partnered publicly with AMD on its Open Telecoms platform and with NVIDIA for GPU-based AI and networking in its data centers. For RF filters and duplexers, Indian players rely on suppliers like Murata, TDK, Taiyuddin, and Qorvo, who dominate the market for surface acoustic wave and bulk acoustic wave filters. Network interface cards are similarly sourced from global leaders NVIDIA, Broadcom, and Intel. Here's a concise summary of how a 5G base station system works. The journey begins at your phone. When you make a call or request a web page, your device sends signal to the nearest cell tower. Massive MIMO antennas on the base station masts, arranged in dozens to hundreds of small antennas, capture these signals by focusing electromagnetic wavelengths precisely towards your device using beamforming technology. The radio unit translates signals, converting radio waves into digital data. Located near antennas, this unit contains the digital front end, which are FPGA or ASIC chips that steer the antenna beams for beamforming, RF filters, which blocks out unwanted frequency noises, RF power amplifiers, which boosts the wanted signals, and converters, which handle signal modulation and demodulation, converting analog waves to digital data and vice versa. This turns raw radio waves into clean digital data streams. The most popular custom ASIC chips are Huawei's HiSilicon, Ericsson's Silicon ASICs, or FPGA chips like Marvell's Octeon. The distributed unit handles local tasks, acting like a traffic controller for the phone connected to that cell. It fixes data errors, decides which devices get priority, and optimizes signal in real time. Located right next to the radio unit, the distributed unit handles very fast, time-sensitive jobs needed to control radio signals sent and received by the antennas. This includes things like modulation and demodulation, converting data into radio waves and back again, forward error correction, adding extra data to fix errors, scheduling, quickly deciding which devices get to use the radio signal, and hard queue management, managing requests to resend data when sections get lost. The distributed unit servers run on commercial off-the-shelf CPUs like Intel Xeons and AMD EPYCs, with hardware accelerators to handle compute-intensive tasks like forward error correction and channel coding. The hardware acceleration is handled by FPGA cards like AMD's Xilinx UltraScale, Intel's Agilex, or custom ASICs like Huawei's HiSilicon. The centralized unit manages connections. It's in charge of establishing and releasing device connections, authenticating devices, and encrypting signaling, coordinating handovers between cells as you move, ensuring seamless transitions from one cell to another without dropped calls when driving. It also forwards internet call traffic between the distributed unit and the network core, shrinks data package to reduce latency, and prioritizes critical traffic based on service requirements, like prioritizing live video calls over emails. The centralized unit servers also run on commercial off-the-shelf CPUs like Intel Xeons and AMD EPYCs, with hardware accelerators to accelerate AI-driven traffic like traffic prediction, resource allocation, and anomaly detection. They are usually housed away in nearby data centers. The 5G core network acts as an intelligent brain of the entire mobile network. It is a fully software-based system built to be cloud-native. This design allows it to run on commercial servers and be deployed with agility across multiple cloud infrastructures. Functioning as a global web of data centers, the core is responsible for authenticating users, managing data sessions, and intelligently routing traffic, like seamlessly connecting a video call from Australia and linking to other networks worldwide. The 6G era characterized by cloud-native architectures, AI-driven orchestration, and Open RAN standardization, presents a pivotal opportunity for Indian telecom gear vendors to expand globally and disrupt established market hierarchies. Historically constrained by hardware dependencies, firms like Starlight Technologies, Tejas Networks, and VVDN Technologies now can leverage Indian software engineering prowess to deliver cost-effective virtualized systems. By focusing on software-defined innovations like scalable vRAN platforms and AI-optimized spectrum management, this will reduce deployment costs by 30 to 40%, making their offerings ideal for price-sensitive emerging markets in Africa, Southeast Asia, and Latin America. Geopolitical shifts will further accelerate this expansion. Western efforts to diversify supply chains away from Chinese vendors have fueled demand for Open RAN systems. Indian companies, bolstered by government initiatives, are building export-ready ecosystems. However, scaling internationally requires overcoming challenges in manufacturing capacity, carrier-grade reliability, and intellectual property. Strategic alliances, acquisitions of niche tech firms, and targeted entries into emerging markets like Indonesia and Brazil will provide pathways to credibility. By capitalizing on 6G's dismantling of proprietary hardware moats and aligning with open network trends, Indian vendors can capture up to 12% of the global telecoms gear market by 2030, up from under 2% today. Early contracts in the UK, Vietnam, and Rwanda signal this potential, positioning India to transform from a regional player into a formidable force in the $100 billion networks gear arena. That's it, folks. Please like, subscribe, and stay tuned.